There's sometimes in an equation when you want to solve for a certain variable. For example, in this equation we're asked to solve for r, and if r were, say, the most important quantity and we were doing multiple calculations with different values of the other variable d, we might want to have r isolated so we could pull up those values quickly and easily. So our goal is to get r all by itself, that is, to have an equation where it's looking like r is equal to some other stuff, and what that other stuff is will be determined by the other parts of the equation. So our procedure says to get rid of the denominators, and basically whenever we're working with an equation, if we get rid of the fractions, it makes our lives easier. In this case, because it is two fractions, two ratios, we are able to cross multiply. So we've got our d times r plus 2, which we'll write out here, is equal to the product going in the other direction, which is r times r5, and we'll just call that 5r. And let's simplify this. D times r gives us dr plus 2 times d, make that 2d, is equal to 5r. And we always want to keep in mind what our eventual goal is, that is to get our r on one side of the equation. So we're looking here at this term, the 5r has an r in it, and the dr also has an r in it. Step 2 says get all terms with the desired variable on one side and all the other terms on the other. So we want to put our r's together. We could move the 2d, but that doesn't really benefit us. In this case, if we move the 5r to the left, we would have our r terms together, but then we'd have to move the 2d. So really the most straightforward thing to do here is to subtract dr from both sides and then put it over on the right. So that's what I'm going to do. On the left, all that I have remaining is 2d is equal to the original 5r, and because we subtracted off, we have minus dr. Step 3 says factored out the desired variable. So our goal in all of this was to get r by itself. And one thing that we can do is pull r to the front because it occurs in both terms, and that was on purpose. We deliberately put all the terms with r on the right. So when we factor out r inside the parentheses, we're left with 5 minus d, and then we still have our 2d on the left. And finally, to isolate the r, we want to divide by the multiplier, which in this case is 5 minus d. And because we did it on the right, we will also do it on the left. So our final answer, our solved equation with solve for r, is that r is equal to 2d in the numerator divided by 5 minus d in the denominator. Next, I'd like to take a look at an equation that's got 3 fractions in it. This is the formula for parallel resistors for those of you taking physics. And because it's not simply 2 ratios, we can't cross multiply here. So we're going to have to multiply by the least common denominator. So to begin, I just first like to rewrite the equation to give us more room. And to clear these denominators, I'm going to have to multiply by the least common denominator, which in this case is the product of all 3 of those denominators. So it's going to be r equivalent times r1 times r2. So I'm going to have to multiply that product by all 3 of the terms. So multiplying, again, that LCD in all 3 places, I take a look at the first fraction, and r equivalent is going to cancel out, so there's no more denominator, and what remains is then simply r1 times r2. From the second term, r1 is what's going to cancel out, no more denominator, so I've got 1 times r equivalent times r2. And from the third term, r2 will cancel out, and then I'm left with r equivalent times r1. So then the next step is to solve for this variable by looking at which terms contain the variable. So I've got R1 in the first term and in the last term on the right hand side. And I want to get all of my terms with R1 on the same side and everything else on the opposite side. And so the easiest way would be to subtract off this term here, and that would leave a term without R1 but put all of the R1 terms on the left. So I end up with R1, R2, and subtracting this off I get minus R equivalent R1, and then this is equal to the remaining term on the right, which is R equivalent times R2. Next step is to factor out the R1, so that again is our desired variable, so I pull the R1 to the front, and that leaves me with the terms R2 minus R equivalent, and that's set equal to R equivalent times R2. And finally, to get this R1 isolated, we are going to divide by that factor there, the binomial factor R2 minus R equivalent, and we'll divide by the same on the right, R2 minus R equivalent. And these factors should be gone, but to tidy that up, I can just rewrite the equation again as R1 is equal to R equivalent R2, whole thing divided by R2 minus R equivalent.